Hello, this is Steve Spear, Spear Talks. I want to go over the last test we had in our class. So the first question talked about plotting this data. Plot V as a function of t. I'm going to sketch the curve that best represents the data. This is actually pretty straightforward. So time and velocity is 0, 0, 214, 423, 630, 835, 1039. Now, if it wasn't for the first 2 points, this would look like a pretty straight line, but it's not a straight line. This is a concave line. And so you got a point for correctly plotting the points. The second point was a smooth curve with positive slope and concave down. A concave down curve starting at the origin. All right, so part B on this question is next. Does the speed of the car increase, decrease, or stay the same? So looking back at the graph, does the speed of the car, well, this is velocity, magnitude of the velocity actually, because it's in italics, but notice that the speed is increasing as we go through time. The y value is increasing. So yes, it's increasing. Justify your answer. The y value, velocity, increases as time increases. So the rubric asks you to, the points, there was 1 point. The correct choice is increase. That's not what you got the 1 point for, but for a correct justification. They included the word magnitude of velocity here because magnitude of velocity is speed. So there's that. Okay. So now BII again is 1 point. Does the acceleration of the car increase? Well, how do you tell what the acceleration from a velocity time graph is? Acceleration is the slope of a velocity time graph. The slope is always positive, but becomes smaller as time increases. What do you mean by that? So if we look back at the graph, as time goes along, as we go from 2 to 4, from 4 to 6, 6 to 8, notice that the slope becomes less. All right. So that was BII. Going on to part C. Explain how you would graph, how you would use your graph to find distance. Well, change in position, change in x, is equal to the integral of the velocity, dt, from A to B. So that means that we are finding the area under the curve and you had to specify from to to 8 seconds. That was worth 2 points. So mentioning area gave you a point. Getting the 2 to 8 seconds gave you a point. Okay. Part D. It says that they gave you the equation. The equation is negative 0.3t squared plus 7t. V is in meters per second, time is to derive an expression for acceleration. Acceleration is the first derivative of time. And so the first derivative of this equation is that. And so on this question, on part D, delta, you got one, it was worth 2 points. You got 1 point for indication that the acceleration is the derivative velocity. So this was worth 1 point. And correctly evaluating the derivative was a second point. Part E. Calculate the position of the car as a function of time. So position as a function of time. Position as a function of time is going to equal the integral from, actually I worked it with the antiderivative of that equation. And the equation was negative 0.3 t squared plus 7t dt. And so add 1, divide by the new number. 7 halves t plus c. But we were told that when time is 0, position is 0, and the initial velocity is 0. So using these initial conditions, we're able to calculate c. So when time is 0, I get 0, so c equals 0. So the change in position as a function of time is negative 0.1 t cubed plus 3.5 t. F, that question was worth 3 points. Basically 1 point for each part, identifying position as the antiderivative or integral, evaluating the integral, using the initial conditions. Part F, calculate the distance. So if you wanted to, you could use that formula that we just did. So the change in position for x is going to be, time is 8. So negative 0.1, 8 cubed plus 3.5, 7 halves, t minus negative 0.1 times 2 cubed plus 3.5 times 2. And I believe this gives you 172.8, and this will give you 13.2, and so you should get 159.6, which seems to be increasing in the number of significant digits. but we're not going to worry about that for a moment. Now, if you wanted to, I think it'd be kind of fun to instead do the integral from 2 to 8 of that function, but it just repeats what we just did, so I'm not going to do it. So that finishes our video. This is this is Spear Talks about the first question on our most recent exam. Thank you.